Hello guys, this video is about power electronics. I will introduce you the term power electronics and later on you will get to know about the different applications of power electronics. So let's get started. See, what is the definition of power electronics? Electronics is the technology to process and control the flow of electric power by modifying and supplying the voltage and current in a form that is best suitable to the customer at the load end. See, power electronics is concerned with the electronic principle into the situation that are related to the power level rather than signal level. This area entirely origins with the silicon controlled rectifier SCR. Which was invented in 1956 by the Bell Laboratory. SCR technology led breakthrough in power handling capability of electronic devices. By minor changes in the structure of signal electronic devices, this led to high performance semiconductor devices with better voltage and current handling capability, which are currently used in the different fields such as in blowers, in fans, AC, battery charger, refrigerator, dryers, HVDC transmission, power factor correction, with static compensators, static circuit breaker, relays, UPS, etc. There are lots of applications. See, power electronics amalgamate the three measures of electrical engineering, that are power, electronics and control. That is also understood from the block diagram here. So the major area are power system, electronics, but at the higher power level, and control engineering. Power source to the power electronics system may be DC or AC. This may be AC or maybe DC, depending upon the application or condition of that location. The output of a power electronic system may be variable AC or DC voltage, or maybe variable voltage and frequency. Thus the power needs to be processed with the help of power electronics devices between the source and the load. This is done with the help of power electronics devices known as power processor, called converter as a generic name. If failure in the converter affects the user, and the loss in the converter is the loss in the overall system. Thus the converter must be reliable and must be made of component having negligible loss, such as semiconductor switches. The feedback component measures the parameter of the load and compare it with the command signal. The difference between the two decides the command for turn on or turn off the power electronics devices. The power processor can be majorly categorized according to their operation. Their basic classification is like this: AC to DC, DC to AC, DC to DC, or AC to AC. AC to DC is basically a rectifier. DC to AC is basically called as inverter, and DC to DC is a chopper, while AC to AC is cycloconverter. Another classification is based on turn on and turn off characteristics, or its gate signal requirement and degree of the controllability. So they can also be categorized as uncontrolled rectifying devices, semi-controlled devices, and fully controlled devices. Example of uncontrolled rectifying device is diode. Their on and off state are dependent on power supply, while semi-controlled devices such as thyristor have controlled turn on by gate signal, but it is not capable to turn off. You can't control the turning off of the thyristor. It is dependent upon the power circuit. While the fully controlled switches such as BJT, MOSFET, GTO and IGBT They can be turned on and turned off by the application of control signals. Now I will discuss the different applications of power electronics. See, the demand for the control of electric power for several control applications includes rotatory or static equipment existing from ages. Power electronics has innumerous control techniques in both motor and non-motor application, some of which are listed here. The first one is induction motor speed control. So the speed of induction motor can be varied by methods named as AC voltage control, voltage by frequency control, rotor resistance variation for control, slip power recovery system control, etc. The cheapest method of controlling the speed of induction motor is to vary the apply voltage by using an AC regulator in each line consisting of thyristor. This is a voltage control method. V by F, voltage by frequency control, is implemented with the combination of rectifier converter with inverter. This inverter can be a voltage source inverter VSI or a impedance source inverter ZSI. Rotor resistance variation is a traditional method employed for the control of induction motor. With the development of power electronics, a static variation in the rotor resistance is implemented with the help of chopper in the rotor. Although a great improvement is achieved with the help of static variation of rotor resistance, but a better method for speed control employing the rectifier inverter system is slip power recovery scheme. As in rotor resistance control drive, the efficiency is low as slip power is dissipated in the external resistance. This is more drastic at low speed or high slip value. Closed loop system named speed control and current loop are usually used for better control and current protection purpose. Now talk about the second application, which is induction motor braking. There are three types of braking employing power electronic circuitry to stop the running induction motor. They are plugging, dynamic and regenerative braking. Besides this, phase sequence can also be reversed with the help of semiconductor devices. Now let's say about the third application, which is DC motor speed control. The prime method for the speed control of DC motor is armature control and field control. In armature control, voltage is varied keeping the field voltage constant, while in case of field control, field voltage is variant keeping the armature voltage constant. Speed control below the base speed is obtained with the help of armature control, while speed control above the base speed is done with the help of field control method. Multi-quadrant operation including forward motoring and generation and reverse motoring and generation can be obtained with the help of different schemes of converters. Speed can be varied by varying the firing angle of the converter. Closed loop control drive can also be used for more precise and detailed control. Now about DC motor braking. Similar to induction motor, DC machine can also be stopped with the help of plugging, dynamic braking, and regenerative braking. This can all be achieved with the help of converters. Now let's talk about the power supply regulator. There are two types of DC power supply regulator that are usually used in several applications such as laboratory and electronic circuits of medical equipment, etc. Name conventional regulated power supply and regulated power supply. In case of a conventional regulated power supply, AC supply available is stepped down to a lower level with the help of a transformer and then rectified into the DC with the help of rectifier. It needs to be stabilized with the help of Zener diode. The disadvantage of conventional voltage regulator are the bulky transformer and the bulky inductor. These disadvantages are overcome with the help of more advanced version of regulator called SMPS. Here AC supply is directly given to rectifier without a transformer. The DC output of rectifier is the input to the high frequency inverter. Now the output of the inverter is reduced to or stepped down to a lower voltage AC with the help of transformer. Now this high frequency low voltage is rectified with the help of a rectifier and filtered using L and C components. As the frequency of transformer is high, from the basic EMF equation, flux required gets reduced. Thus the transformer size gets reduced. Now let's talk about the welding. See, welding is the process of fusing metal pieces together by passing short-lived high value of current through the area of contact. The power required for the welding is I square R. So it is proportional to the square of the current. Current is increased with the help of a step-down transformer. This welding power is controlled with the help of AC chopper. Integral number of cycles can be applied with the help of firing the thyristor for a particular time interval and turning off for a particular time subsequently. This integral number of cycles is obtained with the help of a converter. Now the next application is heaters. There are two types of heating that are done with the help of power electronics equipment. They are resistance heating and induction heating. Resistance heating is done with the help of metallic conductor, non-metallic conductor such as carbon tubes, liquids, and the power electronic equipment named AC chopper. Heating resistor is made of alloys such as nickel, chromium, etc. Its principle is similar to welding, that is integral cycle control of AC chopper. This type of heating is used to heat insulated furnace for production or laboratory purpose. Induction heating is used in several applications such as melting, forging, brazing, soldering, annealing, forging, surface hardening, etc. It is also known as eddy current heating. This is also known as eddy current heating as the heat is produced due to the eddy current. When an alternating voltage is applied to the job, or coil, an alternating current will flow. This current induces an alternating magnetic field. The metallic job in this field cuts the alternating magnetic flux and an EMF is induced in it. This induces EMF causes the circulation of eddy current and thus heat produces. If the supply frequency is increased with the help of semiconductor devices such as cycloconverter, then the eddy current will increase and thus more heat is produced. The induction heating is also currently used for electronic heaters employing a rectifier, filter and inverter in sequence. When an alternating field is applied to the non-conducting material, heat is generated. This heat is due to the dielectric loss and the process is called dielectric heating. The amount of heat depends upon the dielectric strength of the job. This dielectric heating method is used in plastic, wood, textile, rubber, food and chemical industries. Now move to the next application, which is static on-load tap changing gear. To reduce the voltage variation obtained from the load variation, I repeat, to reduce the voltage variation obtained from the load variation, a tap changing gear transformer is required. With the change in tap setting means actually the turn ratio of a transformer is changed to vary the voltage. It requires the making and the breaking of electrical contacts. This is usually done manually. But there may be loads where load disconnection is not acceptable. In that case, we use on-load tap changer. Making and breaking of electrical contacts may cause sparking and pitting or erosion of electrical contacts. Also, it may contaminate the oil of a transformer. Moreover, on-load tap changer has high cost, high maintenance requirements, slow in response, and voltage fluctuation problems. These problems can be overcome with the help of a voltage controller having two anti-parallel control switches. It reduces the transient voltage dips and continuous control of voltage is obtained. Let's move to the next application, static var compensator. These are power electronics devices which supply and compensate the lagging reactive power consumed by the inductive load. It helps in maintaining the constant supply voltage with the power factor improvement. There are various power electronics equipment such as TSC, thyristor switch capacitor, thyristor control reactor TCR, STATCOM, UPS, UPFC, etc. Now talk about the UPS. I hope you all have learned about this device UPS. A simple UPS consists of a rectifier, inverter and a battery. Battery provides the supply to the inverter whenever there is no supply power from the source. However, if any component fails, it stops working. Thus, it is actually not reliable. More reliable system can be obtained by using more components in parallel. In case of a parallel configuration, if there is any fault in one of the inverter, that part can be isolated with the help of a solid state interrupter, which is UPS. UPS must also minimize voltage transient on the bus and supply the power to the critical load during the long power outage. Now let's talk about HVDC transmission. See, generation of a high voltage is limited due to the limitation of DC generator. Thus, it is converted into DC at the sending end and then transmitted. And at the receiving end, it is back converted into AC with the help of inverter. Monopolar and bipolar schemes are employed for the HVDC. Since the series reactance in case of HVDC system is nil, there is no stability problem. Thus, higher operating voltage is possible in case of HVDC. Now, what about static switches? It is a switch having no moving parts. Thyristors are used as static switch for high power application, while power transistor is used for low power application. It has very high switching speed and has long operation life. Since it has no moving component, maintenance is almost not required. Static switches are of two types depending upon the supply, that is AC static switch or a DC static switch. It acts as a relay for AC and DC circuit. If the input is AC static switches are used, while if the input is DC static switches are used. Switching speed of AC switches depend upon the supply frequency, while switching speed of DC switches depend upon the commutation circuitry used. Now let's move to the next and last application, that is static circuit breaker. These are semiconductor devices which provide a rapid and reliable interruption of a continuous current. There may be AC circuit breaker and the DC circuit breaker, and these all are applications of a power electronics processor or power electronics converter. Okay, this is all in this video. Okay, see you. Hope you have liked this video. Thanks for watching.